What is time and space? Time and space are two concepts that have fascinated humans for centuries. We often think of them as separate entities, but they are actually intertwined, with time being a measure of change in space. The more we learn about the universe, the more we realize that time and space are not as straightforward as we once thought. From Einstein's theory of relativity to the concept of quantum entanglement, the nature of time and space continues to be a subject of intense study and debate. In this article, we will explore the fundamentals of time and space, including their definitions, how they are related, and the various theories that attempt to explain their mysteries. Whether you are a physics enthusiast or simply curious about the world around you, this video will provide a fascinating glimpse into one of the most intriguing aspects of our existence. Theories of time. Time is a fundamental concept that is used to measure the duration of events and the sequence in which they occur. However, the nature of time has been the subject of much debate throughout history. One of the earliest theories of time was proposed by the who believed that time was a measure of change or motion. In contrast, Isaac Newton proposed a more mathematical approach to time. According to Newton, time was an absolute and unchanging entity that flowed at a constant rate throughout the universe. This theory, known as Newton's time, held sway for centuries until Einstein's theory of relativity changed it. Einstein's theory of relativity proposed that time was not an absolute, but was relative to the observer's frame of reference. This theory, known as Einstein's time, introduced the concept of time dilation, which means that time can appear to move slower or faster depending on the observer's speed and location. This has been confirmed by experts with atomic clocks, which show that time moves slower at high speeds and in strong gravitational fields. Theories of space. Space is the three-dimensional expanse in which all matter exists. Like time, the nature of space has been the subject of much debate throughout history. The ancient Greeks believed that space was infinite and eternal, while in the Middle Ages, space was seen as a container that held the universe. In the 19th century, mathematicians began to explore the nature of space more rigorously. Geometry, named after the ancient Greek mathematician, is the study of flat or normal space. However, in the early 20th century, new theories of space emerged that challenged that geometry. Geometry is the study of curved space, which can be thought of as the surface of a sphere or a saddle. This type of geometry is essential for understanding the creative of the universe. Einstein's theory of relativity also introduced the concept of relative space, which is the four-dimensional space-time continuum in which all events occur. The relationship between time and space. Time and space are not independent entities, but are intimately linked. In Einstein's theory of relativity, space and time are combined into a single entity known as space-time. This means that time can only be understood in the context of space and vice versa. The relationship between space and time also has important consequences for our perception of the universe. For example, the concept of time dilation means that time can appear to move slower or faster depending on the observer's speed and location. This has important implications for space travel, as astronauts traveling at high speeds will experience time differently than people on Earth. Another consequence for the relationship between time and space is length contraction. This phenomenon occurs when objects moving at high speeds appear to be shorter in the direction of motion. This has been confirmed by experts with partial accelerators, which show that subatomic particles moving at high speeds appear to be shorter than what they really are. Time and space are two of the most fundamental concepts in the universe. Their study has led to groundbreaking discoveries and has challenged our understanding of the world around us. From Newton's theory of time to Einstein's theory of time, and from space to relativistic space, the nature of time and space continues to be a subject of intense study and debate. Whether you are a physician, philosopher, or simply curious about the world around you, the study of time and space is a fascinating and rewarding pursuit.